Thank you very much, Anna, for that lovely welcome. Just one tiny correction, it's I'm at Liverpool Hospital, not Westmead Hospital, but otherwise perfect. So I'd also like to acknowledge the traditional owners of this lovely land on which we meet today and pay my respects to elders past, present and emerging. I'm here today representing Doctors for the Environment Australia. Oh, that's the end of the presentation. Can I just... Sorry. Let's just go to the beginning. Sorry, everybody. Maybe just go slideshow. There we go. Oh, pointer. That's yours. Okay. I'm here today representing Doctors for the Environment Australia, which is an independent, self-funded, non-governmental organisation of medical doctors in all Australian states and territories. And we work to minimise the public health impacts and address the diseases caused by damage to our natural environment. For over 7 years, DEA has been documenting the emerging scientific evidence around the threats to health from the unconventional gas industry. We have expressed concerns that the level of assessment, monitoring and regulation of unconventional gas exploration and mining is inadequate to protect the health of current and future generations of Australians and the ecosystems they rely upon. We've pointed out in many submissions, including several to the New South Wales Government, the potential for public health to be compromised, and a growing volume of international literature on reported health consequences supports our concerns. On this basis, DEA has to date opposed the development of the unconventional gas industry in Australia. Today, I'm going to explain to you how it is that unconventional gas threatens health by eroding the environmental determinants of health, and I will discuss the industry generally, but also explain our concerns about the Narrabri Gas Project. DEA is just one of many medical and health organisations raising concerns about the health impacts of an unconventional gas industry. Others include the Australian Medical Association, the Public Health Association of Australia, and the Climate and Health Alliance, which itself has many health organisation members. So what is unconventional gas? It's coal seam gas, it's shale gas, it's tight sands gas. They all have environmental and health risks, no matter what you hear about one being safer than another. Unconventional, so-called, because these gas resources are low permeability, requiring special techniques such as hydraulic fracturing and surface-to-inseam horizontal drilling to make them commercially viable. Hydraulic fracturing or fracking means just that, cracking rocks with water, and large quantities of water, sand and chemicals are forced down the well at high pressure to create pathways so that the gas flows out. Not all wells require fracking. And we're here in Narrabri talking about coal seam gas today because of the Narrabri Gas Project just to the south. This is the Pilliga, and it's greater than 3,000 square kilometres of semi-arid temperate woodland, the largest such remnant in New South Wales, and as you can see, it's easily visible by satellite. If I can make this work, it is. Not working for me. Not working. Never mind. It's the sort of dark green splodge to the upper right. We'll see if we can get that working. So it's a biodiversity hotspot with 230 species of bird at least, and it's home to threatened species including the koala and the striped wallaby. That's all right. So this is the Great Artesian Basin. And the Pilliga Forest is the southern recharge for this vast underground body of water. It's the deepest and largest aquifer in the world, and it's a source of fresh water vital to inland farming and living for about 22% of Australia's land mass. This is a close-up of the area in question. The top right, you can see Narrabri, just right underneath the DEA sign. Then you've got the Pilliga Forest, and further to the south, you have the Warrumbungle National Park, which is sort of off the southwest end of the area. And some of it's state forest and some of it's national park. Santos proposes to drill 850 coal seam gas wells on no more than 425 sites over a 95,000 hectare project area, and 60% of that area is within the Pilliga State Forests. Santos has said that it has no plans to hydraulically fracture any of the wells as part of the project. Pipeline company APA Group is also seeking approval to construct a pipeline to carry the gas to the existing Moomba to Sydney gas pipeline. This is a close-up of sort of the northeast corner and Bimbawindi, which is where the exploration wells are clearly visible from this Google map that I just got off my computer. An initial 56 exploration wells and a water treatment plant with storage ponds at Bimbawindi were established by the previous owners, Eastern Star Gas. Operations were shut down in 2011 after Santos bought out the company. The water treatment plant was decommissioned. Santos found both ponds and wells not up to standard, and both have required rehabilitation, with 30 wells being decommissioned. A new reverse osmosis water treatment facility and holding ponds have been established at Leewood, 24 kilometres south of Narrabri on the Newell Highway. In February 2017, Santos released its Environmental Impact Statement, or EIS, for comment, and a record 23,000 submissions were received by the Department of Planning and Environment. Greater than 97% of those submissions were opposed to the project. They included 100 submissions by non-governmental organisations, including one from DEA. The project is awaiting final assessment by an independent planning commission. However, no date has been set, and in an unexpected step, the New South Wales Department of Planning has asked Santos to provide further information. But let's get back to some basics regarding human health, and let me explain to you why it's relevant to health. So the WHO defines health as a state of complete physical, mental and social well-being, and not merely the absence of disease or infirmity. I love this slide. It's my favourite slide in the world. It looks like an onion. And in the centre, this is basically a slide of the things that determine our health. Right in the centre are the things related to the individual, their genetics, their age, their gender, their racial background, and in increasingly large circles are the other factors that influence their health, such as their lifestyle, the community they live in, and then, of course, the social determinants of health that we've heard a lot about in recent years. And they are the social and economic conditions that determine a person's health status, and they include factors such as access to education, transport, safe housing, employment opportunities, and the absence of discrimination. But outside and encompassing the social and economic are the environmental determinants of health. And this really is the environment that's conducive to physical and mental health, and it has to have in it clean air, clean water, safe food supply, some contact with nature, and also, of course, a stable climate. These are fundamental to health, but an unconventional gas industry can put them at risk. First of all, clean water. We have to have water quality, we have to have sufficient supply, we have to know how to deal with wastewater and spills, and that relates in particular to the unconventional gas industry. I'll just go through these now for you. Water quality can be threatened by both chemicals in drilling and fracking fluids and by chemicals mobilised from deep underground in the process of gas extraction. The latter include compounds naturally occurring in coal and shale formations, such as heavy metals, volatile organic compounds, and also radioactive isotopes. Drilling and hydraulic fracturing fluids may contain carcinogens, mutagens, endocrine disruptors, irritants, sensitisers, substances that can cause harm to health if the dose and exposure are sufficient. The gas industry uses hundreds of different products and chemicals. Both in Australia and overseas, lack of disclosure of chemical use by the gas industry and lack of assessment of chemicals for health impacts are putting health at risk. In Australia, we have NICNAS, the National Industrial Chemicals Notification and Assessment Scheme, and it's our chemical regulator. But it has not done nearly enough to inform us of these health risks from the chemicals used in the coal seam gas industry. So NICNAS did an assessment of 113 chemicals used by companies in Australian CSG extraction between 2010 and 2012, 59 of which are apparently still in use. The reports were only published in late 2017, so it sort of took them about 5 years, in other words, to get that information out there, and already some of the chemicals weren't being used and presumably other new ones were. So they relied completely on voluntary participation by the gas industry and only assessed risks of above-ground handling of the chemicals, such as may affect workers. It did not consider potential risks from chemicals entering deeper groundwater through drilling or fracturing operations, didn't consider shale or tight sands, nor the underground contaminants. The assessment noted 61 out of 113 chemicals tested were found to be unlikely to cause harm to the environment when used in CSG extraction, even if they were to spill or leak, meaning that 52 could presumably be harmful. And also, it says, in these pre-mitigation scenarios, the majority of chemicals, 73 out of 113 tested, were found to be unlikely to cause harm to public health when used in coal seam gas extraction, even if they were to spill or leak, etc., in large volumes, without the leak or spill being detected or cleaned up, meaning 40 chemicals possibly could be causing harm. And still, in Australia and in New South Wales, there is no mandatory public disclosure of the chemicals that the gas industry uses. Santos have disclosed some in their EIS for Narrabri, but of course they may use others. The chemicals Santos will be using for drilling are similar to those used in other gas developments where health concerns have been raised. And although Santos have said that they won't be fracking, they may decide to do that later on, meaning a much greater volume and variety of chemical use. These are some of the chemicals that are in their EIS. Exposure to people is required, of course, for the chemicals to have an impact. Theoretical exposure scenarios generated in the EIS chemical risk assessment show a wide range of toxicity exceedances for human health. However, this finding was dismissed as unimportant because of theoretical modelling that suggested low likelihood of mobility to water sources. And yet, there is a long history of spills and accidents in the industry, including at this site. The EIS exposure assessment is not comprehensive. For example, glyoxal and other chemicals can be absorbed through inhalation, not just through ingestion in water. Glutaraldehyde is used in X-ray processing, in balming fluid, leather tanning and so on. It can irritate skin mucosal membranes and cause sensitivity. Glyoxal is irritating to mucous membranes, acts as a skin sensitising agent and is genotoxic. MITC is an air pollutant that may cause or contribute to an increase in mortality or serious illness, or that may pose a present or potential hazard to human health. MITC is a strong ocular and respiratory tract irritant and can cause systemic problems such as nausea, dizziness and headaches. These chemicals are hardly the low toxicity or inert substances suggested by the EIS, and there is no guarantee that other chemicals will not be used at the site over the next 25 years. Unconventional gas drilling, of course, can also affect water supply. Firstly, it can require very large volumes of water if hydraulic fracturing is used. Secondly, water must be removed from coal seams before the gas will flow. Coal seam water is not part of the Great Artesian Basin, but removal may lower water levels in aquifers or change the way subterranean water flows. Landholders in the midst of CSG have observed water levels in beneficial draws dropping, sometimes quite dramatically. The Santos project will use a total of 37.5 gigalitres of water, and impacts on beneficial aquifers may not be apparent straight away. With hotter, drier conditions with us now due to climate change, we can't afford to threaten water supplies like this. Wastewater. So coal seam water is very salty. It can contain aromatic hydrocarbons, including benzene, toluene, ethylbenzene and xylene, high concentrations of ions such as calcium, iron, magnesium and strontium, heavy metals including arsenic, cadmium, chromium and lead, and radioactive compounds, thallium, selenium, thorium and uranium. Produced water includes what is produced from dewatering a coal seam or return water after fracking, and it contains chemicals and underground contaminants, and it also, of course, contains large amounts of salt. So produced water might be stored on site or in evaporation or holding ponds, or treated by reverse osmosis. Reverse osmosis recovers 90% of the water, leaving a salt concentrate that needs to be heat treated in order to form solids or salts. And these concentrated solutes or solids are not pure salt, but of course are contaminated by the other chemicals from the coal seam or gas processes. Water treated by reverse osmosis may still contain trace compounds, which, because they are small, remain in the treated water. It is not known which chemicals persist or what their effects are, and this is not considered in the Santos EIS. Water treated at Santos's Leewood Water Treatment Facility has been used for irrigation, although the New South Wales EPA are currently investigating them because they were doing it without a licence. At peak periods, the Narrabri Gas Project will produce 117 tonnes a day of salt. That's enough to fill 2.5 B-double trucks. There's no indication of where the Santos say that this is going to go to landfill, but there's no indication of where that landfill actually is going to be, and even if it is such landfill is available. So what measures are in place to monitor the impacts of burying all this salt? What guarantees are there that this salt will not leach into waterways, damage soils, or destroy habitat? There is no solution for safe disposal of salt that does not threaten water and soils, particularly in our very dry land. Coal seam gas up in Queensland, over the lifetime of those fields, will produce 31 million tonnes of salt, and that's enough to fill the MCG to the brim 15 times, which is why there's 15 MCGs on the side. Spills can and do occur and can and do contaminate surface water. In the US EPA documented, for example, 151 spills of chemicals and fluids when at the mixing stage, and 13 of those spills reached a surface water body. They also documented produced water spills between 1 and 4,000 litres, caused by human error, of course, or equipment leaks and failure, and 13% of those reached a surface water body. And if you extrapolate US spill rates averaged over tens of thousands of wells, so these guys have got some experience of this, to Narrabri, 850 wells will result in 15 to 130 spills of wastewater here. We have to expect it. It's what happens with this industry. But the Pilliga is already no stranger to spills. Between 2009 and 2011, 16 leaks and spills at Bimblewindi Water Management Facility occurred. There was a 10,000 litre spill in June and another one in October of 2011, which caused vegetation dieback due to salt contamination up to 400 metres from where the water was spilled. In 2012, the EPA fined Eastern Star Gas for 2 unauthorised produced water discharge events into Bohena Creek and gave a warning for a discharge event containing high levels of ammonia. In 2012, the New South Wales Government prosecuted Santos for Eastern Star Gas's failure to notify a spill event and lodge reports. In January 2015, produced water was emitted from a high point vent on a water flow line. The EPA investigated only after a report was made by a community member. And in March 2014, New South Wales EPA confirmed contamination of an aquifer caused by water leaking from a holding pond in the Pilliga CSG development. Lead, aluminium, arsenic, barium, boron, nickel and uranium were detected at levels above livestock irrigation and health guidelines. The salty water leaking from the pond had actually mobilised the elements and moved them into the aquifer. Now, this was not a mechanism of contamination that I don't think anybody had thought about. I certainly hadn't. So the uranium levels were detected at 335 micrograms per litre, which is about 20 times the safe drinking water guideline of 17 micrograms per litre. New South Wales EPA fined Santos for contamination of the aquifer, but the leaking actually had been going on for 2 years before action was taken. They tell us it's safe, but the company assertions of safety do not match the reality. Monitoring and compliance and safety is inadequate. The regulators struggle to address compliance in a timely manner, and relatively tiny fines dispensed for non-compliance are therefore no real disincentive for the companies to pollute. Second environmental determinant of health is the air that we breathe. The most common exposure pathways for humans living and working near gas operations is likely to be air, but research is hampered by lack of environmental monitoring, both at baseline and after commencement. Nonetheless, there are well-established health concerns in relation to volatile organic compounds from unconventional gas developments. During extraction, unconventional gas may release fugitive emissions of methane and VOCs from produced water, drilling and fracking fluids, and so on. Diesel emissions from vehicle movements and equipment combine with VOCs to produce ground-level ozone. Ozone is known to produce lung inflammation and increase respiratory symptoms, particularly affecting people with asthma. Rural areas in Wyoming and Utah in the States with intense gas operations have measured ozone levels higher than the worst day of smog in Los Angeles. Air pollution from the existing Narrabri facility, 56 exploratory wells, reported in the last year of data to the National Pollutant Inventory, shows annual emissions of 10,000 kilograms of carbon monoxide, 23,000 kilograms of oxides of nitrogen, and 6,200 kilograms of volatile organic compounds, even in its relatively quiescent small state. What about safe food? The unconventional gas industry risks both food safety and food security. There is a very large and distributed surface impact with 1 hectare well pads every 750 metres, connected by 6-metre wide roads with surface water and gas pipelines. Land area for gas processing, holding ponds and wastewater disposal contributes to competition for land use, loss of viable agricultural activity, and reduced usable land area for cultivation. Contamination of the land with chemicals, increased salinity, damage to soil infrastructure, changing pH, increased compaction, all occur with CSG extraction. Chemical contaminants may end up in crops and livestock and ultimately in the food we eat. Spill incidents have been documented to have dramatic effects on animal health. Lastly, I want to talk about the climate. A stable climate is essential for health. And climate change is the greatest public health threat of our time. The health impacts have already begun and are increasing. Heat, drought, flood, fire, severe storm, inundation, crop failures, conflict, and mass migration, to name a few. This diagram demonstrates the many direct and indirect ways climate change impacts human health, and we're seeing these impacts already. And why is this relevant? Because unconventional gas is pure methane, which is an extremely potent greenhouse gas. Methane is 34 times more potent than CO2 over a 100-year period and 86 times more potent than CO2 over a 20-year period. So there's been quite a few full life cycle analyses of unconventional gas, comparing it to other fuel sources that we burn for electricity. And these show that you only need to lose between 2 and 4% of the gas as fugitive emissions to negate the greenhouse emission advantage that unconventional gas has over coal when burnt to generate electricity. If gas is to provide the maximum net climate benefit versus coal, then the release of methane must be held to less than 1% of the total gas production. And this is completely unrealistic, given that in the US, where they've measured fugitive emissions, the emissions range between 2 and 17% of the gas produced. In Australia, there's been no baseline measurements of methane emissions prior to the CSG industry, and no comprehensive, rigorous, independently verifiable audit of gas emissions. Here in Narrabri, there's been no baseline measurements or direct measurements of fugitive emissions, and none are planned. And there's no plan to assess methane leakage accurately from the operations, such as compressor stations or long pipelines, which can be sources of leakage. There's no indication of how methane leakage will be assessed after wells are decommissioned either, and no indication whose responsibility it will be to monitor wells indefinitely for methane leakage. Why monitor? Because well integrity becomes compromised over time. Rates vary from a few percent to over 40% of wells fail, and given enough time, probably the figure is higher. This means that wells can leak gas and fluids into other underground structures or above ground, between the rock and the well casing. In Queensland, scientists from Southern Cross University have found levels of methane up to 3.5 times higher in the Tara gas field than the highest readings outside it. And the pattern and the identity of the emissions suggests that there's widespread leakage in that area now of methane. This is not counted, it's not counted in Australia's greenhouse gas emissions, etc. So it seems unlikely that there will be any benefit at all to the climate from this project, but also a lot of risk. If we're going to limit the damage from climate change, we need to keep fossil fuels, including gas, in the ground. Gas is widely touted to be a transition fuel, but it's not really, it's a distraction. A 2014 study published in Nature found that unconventional natural gas development will not significantly reduce and may increase climate forcing. Climate change is a slow-motion health disaster of biblical proportions. This is the trump card in the argument against unconventional gas, in my opinion. What about health impacts directly? So 7 years have passed since the Federal Senate inquiry, where DEA and others presented evidence and recommended independent baseline and ongoing water and air monitoring and comprehensive health impact assessments. Still, the only routine water and air monitoring is by the industry itself, and no health impact assessment has been done. However, there is a rapidly expanding body of international scientific studies on health and social impacts of the unconventional gas industry. Long-term epidemiological studies are underway too and have already reported initial results. In Australia, CSIRO has the Gas Industry Social and Environmental Research Alliance, or GSIRA, and this year they released a study design framework for the human health effects of coal seam gas activities, and also project design for the first study into health impacts of CSG activities in the Surat Basin in Queensland. I think we're going to be discussing that later. And it's to follow broadly a health impact assessment format. But as GSIRA is a collaboration which includes state governments and the gas industry, there is concern regarding the work's true independence. The response to health problems reported in Tara, Queensland, has been slow, superficial and grossly inadequate. The Queensland Health Department's own investigation of the health complaints omits 7 out of 9 key steps of international health impact assessment standards. Back in 2014, there's been a lot of warnings sort of published in the literature. I'm just going to show you a couple of those. In 2014, a paper published in Environmental Science and Technology, the authors conclude, despite broad public concern, no comprehensive population-based studies of the public health effects of unconventional natural gas operations exist. The authors report in this paper that US regulators are well aware that oil and gas development pose inherent environmental and public health risks, and that the extent of these risks is unknown because existing studies do not take into account the potential for long-term and cumulative effects. The Medical Journal of Australia published an article in 2014 urging a precautionary approach be taken, as if with a new drug. And in 2015, the MJA published an article by Madeleine Finkel sounding another warning about unconventional gas and human health, urging adequate assessment of health and environmental impacts, citing the relevance of the USA experience and outcomes, and advising precautionary measures be taken accordingly. I'm just going to run through some health studies that we have then. There's been a surge of new evidence on health impacts, and the following are some examples. In 2016, Hayes and Shonkoff conducted an assessment of the peer-reviewed scientific literature between 2009 and 2015 and found no less than 685 papers on public health, water quality and air quality impacts from unconventional gas. 84% of public health studies found public health hazards, elevated risks and adverse health outcomes. 69% of water quality studies found potential associated or actual water contamination, and 87% of air quality studies found elevated air pollutant emissions and/or atmospheric concentrations. In 2016, Rasmussen and colleagues found an association between asthma exacerbations and unconventional gas activity in Pennsylvania. The active phases of production, including pad preparation, well drilling, fracking and production, as well as proximity to the patient's home, was correlated to the incidence and severity of asthma attacks. Gas activity was statistically associated with increased asthma attacks of all severities. In 2016, Casey et al. Studied birth outcomes in over 10,000 births in Pennsylvania and found an association between gas activity and preterm birth as well as high-risk pregnancy. 2018, Whitworth reproduced similar results and found increased preterm birth among infants born in Texas gas fields, especially associated with the drilling phase of gas development. In 2016, Werner et al. Studied hospitalisation rates, this is an Australian study, in CSG versus coal versus rural areas of Queensland, and found increased admissions for cancers and blood or immune disorders in the coal seam gas area. In 2017, Stacey reviewed and summarised the epidemiological health literature on unconventional gas. That paper found preliminary evidence linking respiratory outcomes, asthma, and fetal outcomes, reduced growth preterm, and Stacey notes that proximity is used only as a surrogate measure of exposure and concludes that personalised monitoring is urgently needed. So do we really need and want this industry in Narrabri or in New South Wales? The Institute of Sustainable Futures at UTS published a report this year comparing the proposed Narrabri gas project with the development of wind and solar power. It examined two scenarios, an ambitious scenario and a modest one, both of which would result in the export of renewable energy from Narrabri to the national electricity market, as well as providing 100% of Narrabri's energy needs and creating ongoing energy generation rather than being limited to the life of the gas field. This is a table that I've created using figures from the report and comparing the gas project, the advanced scenario, which is the middle column, and the more modest scenario. And you can see the comparison in terms of land use. The renewable energy scenarios use far less land, only a fraction cost, and also sustainable jobs. So you can see that in terms of jobs into the future, the renewable energy scenario provides far more sustainable employment for the area. So, to summarise, the risks are clear enough. We have enough evidence that air and water have become contaminated. that spills can and do occur, and that fugitive emissions make gas a climate change villain, not a guardian angel. We have enough evidence to see that the environmental determinants of health are being compromised, and the emerging health studies confirm our concerns. It's just not worth it when we have safe, cost-competitive, low-emission alternatives in renewable energy now. New South Wales does not have to go down this path. Victoria has banned unconventional gas altogether. So can New South Wales. Today I've shown you how unconventional gas erodes the major environmental determinants of health, entailing clear risks, harms that are occurring and emissions that we must avoid. The Narrabri gas project is unwanted, unhealthy and unnecessary. Thank you.